Welcome to another episode of Axians Networks, where today we'll be discussing cybersecurity in the industrial sector. Here with me today are Thomas Menze. So Thomas is a senior consultant at the ARC Advisory Group. Thomas is part of the automation team at ARC, covering process industry related topics across Europe. His focuses are distributed control systems, functional safety, IT security, energy efficiency, and the physical layer components between the field instruments and the control room. Thomas also specialises in process automation trends, technical customer expectations, and market research. Thomas has a strong background in the process market and is speaking to us live from ARC's offices in Germany today. Welcome, Thomas.
Welcome, everybody.
And we also have, and I should say very privileged to have the eminent Lee Fisher of Juniper Networks. Lee, you've been described as an IT security guru. I think that's fair to say from what we're going to hear today. You have more than 20 years at the sharp end of IT, a noted public speaker, I should say. And it said your passion and style, I have to say I feel woefully inadequate with my shirt today, stand out in the sometimes staid world of network security. Prior to joining Juniper, Lee has held positions technical roles at Dr. Solomon's, McAfee, Hewlett-Packard, to mention a few, and now heads up the Juniper network security business across EMEA. Welcome, Lee.
Thank you very much for inviting me.
So, to position why we're here today, we're going to jump straight in. So, industrial automation and control systems, IACs. May I call them IACs? Is that okay?
You can call them whatever you like.
So, this is a general term describing automation systems responsible for data acquisition, visualization, and control of industrial process. So, it's machines that do things.
Yeah.
So, found in various industrial sectors, so chemical plants, car production lines, or in critical infrastructures such as water utilities, power utilities. They play a critical role in maintaining the continuity of the industrial process, but they also serve, as I understand it, to ensure functional and technical safety, preventing large industrial accidents and environmental disasters. But without the right level of security, one could argue that they themselves are a disaster waiting to happen. So if you wouldn't mind, Lee, could you just sort of bring to life or paint a picture of what we're talking about here?
Yeah, sure. I mean, effectively, most of the things that make things, the things that actually keep our water and lights on at night, the things that actually we rely on in terms of, the automation of equipment, in terms of production lines, assemblies, in terms of energy supplies, water supplies, the cleanliness of the water, all of those things that are connected and do something on it in a business or some form of critical infrastructure, they slowly over time become more and more less stovepiped or less air-gapped from what is the IT world today, and they've coalesced. So they've come together. So the businesses are doing that because of an operational sort of efficiency and cost-saving perspective, and of course in the process of doing that, there comes new inherent risks. And in summary, really, and I'm sure we'll dive into some of this detail later. There's evidence now going back over 12, 13 years in the sort of scale and scope of these threats that are coming at these industrialized control surfaces and systems, in terms of the attacks and the opportunity that's there for cyber criminals and state actors to exploit. And there's lots of evidence of that's underway today.
And I think we are going to cover that as we go through today. Thomas, reading the ARC Advisory Group's website, it's clear that digital transformation in the industrial sector has already begun. Now, whether we call it the Industrial Internet of Things, IIoT, or Industry 4.0, industrial companies have already begun to use the available technologies to completely reimagine their business model. So for a lot of those companies, there's benefits and opportunity here to improve asset performance, to provide new service offerings, and improve operational efficiency, and find completely new ways of offering value to their customers. But that all comes with risk, as we've just been hearing about. So, Thomas, how does the ARC Advisory Group help customers identify and incorporate the latest industrial Internet of Things related developments, if you like, and best practices to stay protected in this evolving threat landscape?
Okay, David, thank you. That is really a long question. So let me start 30 years ago. So ASC was founded in the US, in the Boston area. And since that, we are working together with asset owners, end users, automation suppliers, and software companies, really to provide market intelligence with a strong focus on automation applications. And today, 30 years later, these cyber incidents and cyber threats are really serious. And as you said before, the process-related industry belongs to the critical infrastructure. If somebody takes over control from the outside, this can have a dramatic impact. And we are really providing market surveys first, best practices, talking to the automation suppliers, to the software companies, adding value, cybersecurity value to the asset owners and end users. That they know what's available in the industry, and of course we are tracking seriously the threat landscape. So we are providing information. What is maybe a risky attack, and what kind of preparation is necessary for the asset owners to withstand.
Okay, so there are clearly security risks there, and what we do know is over the last 10 to 15 years, the industrial automation and control systems have become more vulnerable to these security risks. And I think we were discussing earlier, and you did reference it earlier, that the heavy use of commercial off-the-shelf technologies such as Microsoft Windows, SQL, Ethernet, means that these control systems are now just as vulnerable as our IT systems are to viruses, worms, Trojans. In fact, there's been much publicised attention in recent years. Can you reference a few real-world incidents here that underline the point we're trying to make?
Yeah, I mean, there's again, if you dig below the surface, turns out there's actually quite a few sort of individual threats as well. I mean, if you go back in time, there's evidence that said that this journey that we're at today actually started as far back as 2005, when some of the components were originally being put together for what maybe later turned into Stuxnet and things like that. I think a lot of the audience may or may not have known about in terms of the attacks that were aimed then at the Iranian sort of nuclear production facilities. But there's additional. So I mean, there's a whole series of sexy names associated with these threats. There always are. I don't know exactly where they always pluck them from, but Black Energy, Black Energy 2, Black Energy 3. Each of these have sort of slowly enhanced and evolved the actual capabilities of these threats, going back from, I think, 2007. The original one was just a DDoS tool, so it would deny access to types of technology. But then Black Energy 2 and 3 started to actually take that concept a little further in understanding what's on somebody's network. So what industrial control technologies is an organization using? Version 3 of that started to actually go a little bit further by having some sort of remote control or capabilities back to some sort of centralized point from afar. In other words, not the original operator, somebody else. You've got other threats that were surfaced. HVAC was another one that appeared in 2013. That was actually, interestingly, leveraged what we call a watering hole opportunity, in the sense that these criminals went after the technologies that the operators were likely to be using, and that was by attacking the technology on the vendor's website. So they hacked in and actually changed the software that someone would download if they were actually legitimately using this technology. It's called a watering hole attack. They'd go to where these vendors were likely to end up. And then through that started to actually cause significant disruption. One of them was related to Ukrainian sort of potentially state-orientated attacks by Russia in 2015 that actually attacked Ukrainians' power grid. There was another attack, essentially, that was surfaced last year, crash override, as it was called. That actually was responsible potentially for damaging again the Ukrainian infrastructure. So about 250,000 people were lost, had no power. And then the most recent sort of threats that we're seeing today, Triton, or Tritis, I think the name for it, is essentially a threat that looks to actually attack one thing that you were talking about earlier, which was the actual safety technologies associated with their safety information systems that were actually there to help and govern this technology that organizations are using. deliberately to actually do something else to them. So there's a whole range of threats that we've seen evolving over that period of time. And actually, the interesting thing is, becomes a lot of state-orientated sort of conversations. Is it the Americans and the Israelis going after Iran, or is it the Russians going after the Ukraine? These are interesting conversations,
which we couldn't possibly cover,
which we can't cover today. But the reality is, what's actually going to affect, I think, most organisations is actually, look at where the cyber criminals make money today, and that's in ransomware, and that's holding an organisation to ransom and denying them access to some form of technology or data inside their business. So I think that what we're seeing on this evolutionary path is eventually we'll get to a point where all manufacturers potentially, or anyone in the supply chain potentially, could effectively be held to ransom by those organisations being denied access to their infrastructure, their
so stopping
production lines, and everything else. So there's the threat is maturing at the same time as industry is adopting more open standards, and that's what really we need a cautionary tale towards. It's don't just do this blindly. There's lots of standards which we'll touch on now coming along, which are there to help advise and govern us, and we just need to listen and look at these practices.
So, Thomas, would you like to respond to Lee?
Yes, of course. First of all, I think Lee summarized the situation fantastically. But really, let us keep in mind and let us agree, this cannot be reduced to a secure technology only. We need really the humans, the processes, and the technology in place. And these three things, they have to be set up in a secure way. That means we have to train the people, we have to define the right processes, and we have to install and use the secure technology to achieve a decent level of security. So that is my initial response to Lee's statement. But coming back to your question, David, yes, we have some independent research, and this is important here because so much rumor is going on the web. So it is really important to get some independent research institutes where we get solid data from. And one fantastic search is the ICS CERT, that is the Cyber Response team of the Department of Homeland Security in the US, and they are really analyzing the critical infrastructure every year. And the latest data we can get is the financial year 2016, and they did 130 assessments there. Thereof 50% of these assessments targeting the design architecture. And that is absolutely in line what Lee already said. So if the Department of Homeland Security did these assessments, they find 700 critical discoveries really in the critical infrastructure network. And again, the critical infrastructure is a conglomerate of the energy industry, the logistic and transportation, the water and waste industry, and of course, government networks. And I think these kind of assessment will be done year by year. And we see always an increasing number of incidents because if you compare the 2016 results against the 2015 results, you easily find out 2015 from the attacker side, water and wastewater and the energy industries, they were under attack. But in 2016, obviously, the attackers, they changed their scenario, their strategy a little bit, and they're now targeting, again, water and wastewater and energy, but they found as new industries, the chemical industry, and of course, the general communication. So as we can see, it becomes more and more tricky to withstand the attackers' sophisticated incidents. And because of that, let's say all the end users and asset owners, they have to take really responsibility to secure their applications up to a decent level. And that is, of course, necessary to withstand against this threat landscape.
So trying to tie those two pieces together there, I mean, the strategy of these cyber criminals is going to change. They're probably going after the money a little bit in terms of the organisations which they attack. The point here, though, is that with the sort of potential extent of the problem, you'd have thought that more industrial companies would take the necessary steps to protect themselves, but statistics tell us that it's not the case. And specifically that the industrial sector, which we'll take as a whole, treated as a whole, is lacking when it comes to cybersecurity. So what are the barriers, and why are these companies not putting in place the necessary security to protect themselves against the cyber attack, Lee?
I think, there's so many answers to that one, David. I wish there was just one and we could apply the silver bullet, right, to fix it. But the truth is that it's a multifaceted answer there. Yeah. I think actually Thomas pointed and illustrated in response to my initial point one of the key issues, and that's people. If we look at where does first of all, for any attack to be successful, they have to launch it. They have to get it inside that organisation. And actually, it's the human, squidgy bits, right, us, that actually the prime target here, the initial easy target. We're the lowest hanging fruit in the sense of creating something that we're likely to be tempted by to open and run. I mean, this is a known attack model that actually works, or put something on a USB stick and leave it in a car park. People are people. And so he's absolutely right. If we can't fix this issue, then actually what the rest of the scenario is that we're putting in place is a consequence of that. And so, we can't change us overnight. It's about continuous education. It's about understanding how we actually think about what it is that we're doing with electronic communications coming into the business, what we do with regarding opening content, where we go online, what we trust inside the business. It's also then down to some layers around that in terms of our behavior, some of the technology aspects in terms of what equipment do you actually have? What's its purpose? What's its role for you? How is it segmented away from other parts of the business? These are actually difficult challenges for organizations to first identify what they're using on their network, and then secondly, how to actually protect it. And against an adversary that is continuously changing its attack as well. They don't sit still. In fact, most of the things that you talked about there were actually, they're finding their feet. This is baby steps, what we're seeing at the minute. This is a fertile opportunity over the next few years for them to go after. Because to date, what we've seen is, what happens in terms of most organizations is the threat vector is an email that will come in, maybe a phishing email, someone's targeted you specifically with something you're likely to open. It runs on a machine, and then it's hoping to find other Windows-based, usually machines inside the network. Well, is that the best way for them in the future? Or is the access to what they're looking to achieved by attacking another Windows human, a PC with a human on it? And the reality is that, as we've already seen by a number of these attacks today, the answer is no. They're actually going after the things that you and I aren't sitting at in terms of an interface. They're actually targeting a piece of equipment that's producing something or creating something or pumping something and so on.
That we can't see.
That we can't see. And unless we're sitting there doing this or talking up, making sure on a production line it's getting the right torque for something, for example, to make sure it's tight for suitable for a quality of goods that they're creating. Well, how are we going to validate that? If we go back to the critical aspects of all tenets of security, confidentiality, integrity, and availability. This is talking about are we able to provide and ensure the integrity of the business and the actual systems that are going to respond to information and controls coming to them, and are we validating that they're actually those controls are legitimate from people inside the business? One of the recommended guidelines that we've seen from the Department of Homeland Security and inside IEC 62443, which is a standard specifically designed to look after ICS security, is let's make sure that the devices that are talking to and giving control and instructions to the equipment that you're using is in a specific dedicated tunnel. It shouldn't come from anywhere else. And so it's very difficult for organizations to keep on top of all these changes that are happening at the same time. So I wish there was here's the answer, I've got it, it's called this, and let's do this and we're safe. The reality is it's going to take several lessons, several iterations of this, and a continuous learning curve on behalf of us, the users, the implementers of these technologies, and of course the cyber criminals teaching us these lessons.
But that is the inherent problem here, isn't it? That it's an evolving risk.
Yeah.
And it's always going to change. So we've had a conversation before, the three of us, and you've just mentioned there the Department of Homeland Security. And they've actually issued some guidance which about defence effectiveness. Thomas, would you want to pick this up?
Yes, of course, because DHS really, they analyzed 2014 and 2015 the cyber attacks, and again they analyzed several hundreds, and they came up with let's say with a best practice for the asset owners, because they said if the asset owners have used 2014 and 15 really 7 strategies, just 7 strategies, 98% of the attacks could have been prevented. And again, this is not brand new because it goes back to the year 2014 and 15. But they said if implementation, if application whitelisting and proper patch management, and of course, a reduce of the attack surface and manage the authentication to the control system, and of course secure the remote accesses and monitor and respond to anomalies. If these 7 tasks are combined in the right way, again, 98% of these incidents could have been prevented. I think that is a strong statement, and Lee explained that before, but I like to add, implementing security is not a one-off. It is a constant process. That means if we implement something today, we have to monitor the effectiveness and have maybe to change it according to the threat landscape in future. That means we have to audit our security system frequently to really be prepared against the latest threat landscape and against all these kind of attacks.
Seems to me, sitting here, that humans are the problem here. in a lot of respects.
Are we doing our job?
Yeah, exactly. It sort of seems a simple thing. If we carried out those things that we should do and took advice and heeded that advice and executed upon that advice, we wouldn't have half the problems that we have. But there we go. We seem to. But also, in terms of difficulty, I'm thinking of all the parts of the manufacturing life cycle here. So, of which I believe there are 5. If each one of those, they're normally disparate, so the manufacturing life cycle is disparate in most. I'm talking about here the production, the transportation, the actual use, and then recycling, and as it goes around. So where these things are linked together, surely if one of those parts of that cycle is inefficient or has massive inefficiencies in its security, that's just going to be the weakest link in the chain, and everything's going to fall down. So how do you measure security performance across the supply chain, Lee, or which we can agree would be disparate, and how do you sustain those gains that you make if you do get that together when you suddenly have changes in that supply chain? So that again seems to be very fallible and very human. So
yeah, and it's also another one of your large questions.
Sorry,
you're soon becoming known. How do I solve the world?
Yeah.
Soon.
we're getting our money's worth.
Yeah, you're So what you're basically saying is, in many ways, from an IT perspective, let's put it this way, because I think it might be a nice bridge. Is we've been talking about secure DevOps for a good couple of years now, and what you're talking about is, not just in developing code in a secure way. We've started with Microsoft's trusted computing in the early noughties, I believe it was, but we're still learning and doing that now in terms of just software code. Actually, what you're inferring there is, a whole new development, manufacturing, and production base. And the word critical in critical national infrastructure is an important word and shouldn't be overlooked. But these sectors too need to start to apply these things from an end-to-end perspective. And that's really what you're referring to here, is that it's an end-to-end cycle that we need to do. And it has to have and incorporate an iterative process too of improvement through that way. Thomas talked about it and touched on it a little earlier when he talked about the 98%. and that doing these practical things will actually minimize that attack surface. There's also a shift that's happening already in IT security that we shouldn't overlook here and needs to be brought around, and that is behavior. You know, it's creating a model of normality, and in fact, this is one of their recommended guidelines as well, so it's not like I'm plucking something out of the air here either. But essentially, the more you understand the nature of the business, the more you understand the nature of these systems and what they should and shouldn't be doing, then effectively, it's easier to identify when something starts to go wrong. And if a centrifuge, for example, has a red line limit, spinning up at a certain RPM per minute, then if you notice that that's actually gone up, what's recording that? Are you listening to that? Are you tracking that? Is there something that you should be doing in response to that? This capability is there, and it's a case really of starting to leverage behavioral technologies as well as a way of helping these managers who have got to look after it, because there's so much for organizations to be dealing with now in terms of their digital footprint, in terms of threats, that, you know, it's difficult for these guys, and usually a very small team of skills and personnel, to be able to respond in time. And so while you've got that time window there, that's the 2% that we're referring to. There's something will slip by, and it's about having the relevant capabilities in place that identify and catch those things that you can't stop by doing best practice all the time, you know. But it's incredibly difficult. But effectively, we're looking for an end-to-end sort of cycle here of being able to, you know, look after this in its entire life cycle, not just an abstract part of it.
So you were just talking about monitoring machines' behavior.
Yeah.
Yeah. Okay. Yeah.
Absolutely.
I was struggling at the beginning.
I'll give you a real an example, and it wasn't specific. This was a threat that wasn't specifically targeting, you know, industrial control services, but it's exactly the same type of challenge that we're talking about here, and it's a nice example, and everyone will usually recognise. WannaCry, okay. WannaCry, a piece of ransomware. We saw it in last year. Essentially, what we were talking about was a threat that came onto a business and stopped people accessing systems. Stopped people accessing systems. Well, effectively, you know, from a digital point of view, you know, that's the capability we're talking about now from attacking an industrial threat. And effectively, what you're doing is instead of looking at identifying a bad thing for exactly what this binary piece of code is, you're looking for the behavior. So the behavioral traits that were being exhibited by this piece of ransomware really should have been identified and stopped. So it's the behavior of things that matter. What something does is more important than what something is.
No,
yeah? And it's basically we need to start leveraging this technology more in the future.
Which kind of nicely brings me on to investment in so much, you know, typically how much would customers be looking to invest to secure themselves against cybercrime? I'm going to ask Thomas, would you like to respond to that question, please?
Yes, we have conducted a research on this topic, and we really summarized a rough estimate of costs in control systems. And first of all, we clustered the control system in small, medium, and large systems. So the smaller systems, they represent an investment of roughly $30,000. The medium system represent 125, and the large systems they represent 350,000. So if we following the security procedures according to the guidelines, the 62443 or the NIST framework, typically you have to add application whitelisting, you have to do frequent patch management, you have to use authentication systems, you have to secure all the remote interfaces and accesses, and maybe you monitor anomalies in your communication line. And really, the surprise was, if you analyze these three DCS system sizes regards investment of security cost, not much cost is really necessary to secure a system. So at the end, we got for the small system a value of less than 5% of the initial investment is required to secure such a system, 3% for the medium-sized system, and less than 2.5 of the large system. I think really this kind of investment is a very good investment, because it guarantees the effectiveness and the availability and integrity of the system, and of course the safe functionality. And so again, I think it is not a question of capital expenditure. It goes back to human behavior and again processes, because you have to have the right processes to use this investment in the right way.
Percentage of revenue of the
percentage of the initial capex, the capital expenditure. Again, if I say for a small system you need less than 5% on top of the initial investment. If the initial investment was 30,000 euros, you need less than 5% additionally to secure this kind of control system.
Sounds like good money invested.
Well, it does. When you think how little then it seems that we need to be investing, that's a bit of a no-brainer. And then if we look at human element being a majority of the problem, it seems almost that it's a relatively easy thing to fix.
Yeah, no, I agree. I agree. I think one of the and that highlights really the difficulty in the human piece. You know, because it is only a 5% investment, so why are we not implementing it? Well, the reality is a lot of that technology that which Thomas was just describing, most organizations have acquired that type of technology somewhere else in their business already. So its question is have you tuned it in? Have the people put in place the actual necessary checks and balances to make sure that you're actually acting in the way that the best practice guides us? Because again, the best practice is there. The actual technology exists, therefore, and the investment is relatively small, as we've just heard. So the key question is, it goes back right to the beginning to what Thomas's point was all about. What are the humans doing? What are we doing?
Yeah, and in terms of principle to practice, we've talked about and heard a lot of the principles behind how we can improve cybersecurity. But that's all well and good. But I think a lot of the valuable assistance, if we can call it that, will come from case studies, will come from learning by mistakes.
Yes.
But you know, these are not readily advertised because people don't like to sort of say, "Well, we've just been hit, and stuff's gone missing." Yep. So that might not be so easy to do. Thomas, is there a sort of a guidance or in sort of maturity, cybersecurity maturity planning that ARC talks about?
Yes, we developed in our international forums together with the asset owners and end users and system integrator partners, really a maturity model where we can support the asset owners again on the processes, on the education of the humans, and of course on the available security technology. And we have consolidated all this information in a little best practice guideline, which we provide to our consulting customers, and helping them really to implement and prioritize the security, let's say, integration into their control environment, because this has to be done always bespoke according to the threat landscape and of course according to the installed control system. Because we can offer only a rule of thumb, and we can provide checklists where end users can ask themselves, hey, are we doing the right things here? And are we doing things right? But at the end, this is at least a consolidation of the favorite guidelines and standards, the 62443 and the NIST framework. And it is something which is really practical to use for system integrators and asset owners.
So sadly, we're out of time, but what an incredibly interesting, thought-provoking and serious subject. I'm sure we could talk for many hours more. My thanks to our guests today, Thomas Menze and Lee Fisher. My name is David 18. This was an Axians Network production for Disruptive. Thank you for watching, and we'll see you next time.